Welcome back to the deep dive. So today we are planting our flag firmly in the present, the near future. Let's call it February 2026.
It's a fascinating time for AI, that's for sure. A bit chaotic.
It really is. I mean, if you look back, the entire industry has been completely obsessed with one word, agents.
Oh yeah, the agentic era. Everything had to be an agent. Let the AI do the work, not just, chat about stuff.
Right. We went from chatbots that talk to agents that do. The promise was huge bots booking your travel, writing code, handling customer support from start to finish.
Basically running your life.
Exactly.
Right.
But while everyone was heads down building these things, this huge silent bottleneck started to form. And I don't think people were really paying attention.
We built the digital workforce, but we kind of forgot about the management layer.
It's a perfect way to put it. You have thousands of AI agents running around, but how do you know if they're actually doing a good job? I mean, who watches the watchers?
It's the classic evaluation problem. And for the longest time, the answer was either, humans, which just doesn't scale.
You can't read 1 million chat logs a day.
Not a chance. Or other AI, which historically hasn't been great.
And that is exactly what we're digging into today. We're looking at a brand new framework from the Mosaic AI research team at Databricks. It's called MemAlign.
And looking at the materials, this feels different. This is not just another little update.
No, it feels like a fundamental shift. They're moving away from what you might call brute force training, which is heavy, slow, expensive, and into something that looks a lot more like, human memory.
The claims are pretty bold.
They are. We're talking cost reductions by orders of magnitude, making AI judges actually useful for businesses. So let's unpack this. What is the core mission here? What's the problem they're trying to solve?
The mission is to break that evaluation bottleneck. So think about it like this. You have a customer service bot. You need to know if it's being polite.
Right.
You can't read every log, so you use another AI, an LLM judge, to grade the first one.
AI grading AI. It's turtles all the way down?
Exactly. But the problem is, those judges, they're expensive, they're slow, and frankly, they just don't get it. They don't have the context.
Okay, so that's the core of it. MemAlign is supposed to fix this by giving the judges what do they call it? A dual memory system.
Right, so they can learn from human feedback without this massive retraining process every single time.
Dual memory sounds very sci-fi.
Yeah.
I definitely want to get there, but let's stick with the pain point for a second. Why do these LLM judges not get it? I mean, if you have a top-tier model and you ask it, is this email rude? Why does it fail?
It's what the source calls the domain expert disconnect. An out-of-the-box model, even a huge one, is a generalist. It's read Wikipedia and Reddit, but it hasn't read your company's internal wiki.
Or the employee handbook.
Exactly. It doesn't know your specific database schema or your brand's voice.
There's a great example in the research about SQL code that really it nails this point.
Oh, the SQL scenario is the perfect illustration.
So an AI agent writes a query to pull some data. To a generic AI judge, the code looks great. The syntax is correct. It runs, it pulls data. The judge stamps it, approved.
Thumbs up. But then a human, a subject matter expert, your lead data engineer, looks at it and immediately fails it.
Why? What did the human see that the AI missed?
Context. The AI might have queried a raw, messy data table instead of the official certified view. Or maybe it forgot a crucial filter, like status does not equal canceled. A generic model sees a working query. A business expert sees dangerous, unverified data being pulled into a report.
So it's technically correct, but professionally it's completely wrong.
Precisely. And you see this pattern everywhere. Take customer support.
Right, the double charge example. This one felt very real to me.
So walk us through that one.
A customer is upset about being charged twice. The bot replies, "You were charged twice. It will be reversed in 5 to 7 days." Factually, that's true.
And a generic judge would look at that and say, yep, accurate, pass.
But a human manager sees that and fails it on the spot. It's just too cold, too transactional. It didn't start with, "I'm so sorry for the confusion."
The judge is checking for facts, the expert is checking for empathy and brand voice, and this gets even more serious when you get to safety.
The delete files scenario. This is where it gets really tricky.
Right. A standard safety filter sees a user command like delete all files, and it just screams malicious intent and blocks it.
It assumes you're being hacked or something.
But what if that user is a system admin running an IT cleanup script? In that specific context, it's a perfectly valid, safe request. It's their job.
And blocking it makes the tool useless. Okay, so I get the problem. We're using generic AIs for specific nuanced jobs. So before MemAlign, how do we try to fix this? The sources list a few options, and none of them sound great.
They're painful. The first one is prompt engineering.
Ah, yes, the art of basically begging the model to do what you want.
It's like playing whack-a-mole. You tell the judge, make sure the tone is polite. Then it approves something polite but factually wrong. So you add, also check for facts. Then it starts getting weird about grammar.
You fix one thing and break 3 others. It's just not scalable, is it?
No, it's a dead end. Way too brittle for enterprise use.
Okay, so that's option 1. Option 2, fine-tuning. This is the heavy-duty option, right? Retraining the model on your own data.
Yeah, and it works, but it is a huge lift. You need thousands of examples. You're talking GPUs, time, money. And the worst part is, by the time you finish the whole process, which could take weeks.
Your business rules have already changed.
Exactly. It's like printing a textbook. Once it's printed, you can't just fix a typo.
And the last option mentioned was prompt optimizers, like DSPy. I've heard good things about them, but the report here seems critical.
Well, DSPy is a fantastic tool for many things. But for this specific task, aligning a judge quickly, it's just too heavy. A single optimization run can take minutes, sometimes hours.
An hour. If you're a developer trying to iterate, that kills your workflow.
It just completely breaks the creative loop, so you're stuck. Brittle prompts, expensive fine-tuning, or a super slow optimizer.
Enter MemAlign.
Enter MemAlign.
Okay, so the paper calls it a lightweight dual memory system. Let's break that down. What does that actually mean?
The easiest way to think about it is how a person learns a new job. If you make a mistake, say you use the wrong cover sheet on a report, your boss doesn't send you back to college for 4 years to retrain your whole brain.
No, hopefully not. They just say, hey, use the blue one next time.
And you just remember that. You align your behavior based on that specific memory. You don't rewire your entire neural network. That's what MemAlign does. It aligns the LLM using natural language feedback.
Okay, and it organizes this feedback into 2 kinds of memory, semantic and episodic. Let's define those because this seems to be the core of it.
It is. So semantic memory is for general principles. Think of it as the rule book.
So in the SQL example, when the expert says, no, always use the certified view, the system learns that as a general rule.
Correct. It abstracts that specific correction into a broad guideline. It's like it writes a new page in its own little employee handbook. Rule, prefers certified views.
Okay, that's the rule book. What's episodic memory then?
Now, this is the really cool part. This stores specific experiences. It saves the actual examples, especially the tricky edge cases where the judge got it wrong before. They act like precedents or anchors.
So like in that tricky customer service case, MemAlign would actually save that specific conversation as an example of what to do.
Exactly. It remembers, in this specific situation with an angry but technically wrong customer, this is the correct response. It's like a lawyer looking up case law. You have the rules, but you also have the precedents.
So how do they work together? A new query comes in. How does it use both memories at once?
When a new task arrives, MemAlign creates what it calls a working memory. It dynamically pulls the relevant rules from semantic memory like check for certified views, and at the same time, it searches episodic memory for the most similar past examples.
Wow. It's literally thinking like a junior employee. Okay, the handbook says do X, but I remember last week I got in trouble for doing Y, so I should probably do Z.
That is the perfect analogy. And because it's just retrieving information from a database, not changing the model's core weights, it's incredibly fast and flexible.
I want to touch on the tech behind that retrieval. It mentions a vector database. Why is that specific piece of technology so important here?
It's all about scale. If you just had a long text file of memories, the model's context window would fill up and it would choke. A vector database lets the system search through millions of examples in milliseconds to find just the relevant ones.
So it doesn't have to hold everything in its head all at once, it just knows where to look?
Precisely. It can have a massive searchable corporate memory with almost no latency. It's effectively infinite memory without the slowdown.
This memory versus training structure leads to what I think is the killer feature for any real business, the delete button.
Oh, absolutely. The ability to forget is almost as important as the ability to remember.
The sources quote Stephanie Walter from Hyperframe Research on this. Why is being able to delete a memory so revolutionary?
Because with traditional AI, forgetting is nearly impossible. Let's say your company's return policy changes from 30 days to 60 days.
Okay.
A fine-tuned model has that 30 days idea baked into its mathematical weights from thousands of examples. You can't just take it out.
You'd have to retrain the whole thing, which takes weeks and costs a fortune just to change one number.
Exactly. It's like trying to unbake a cake. With MemAlign, that rule just exists as a piece of data in its memory. You just overwrite it.
You literally just find the memory that says return window is 30 days and change it to 60.
Or just delete it. Stephanie Walter called it an overwrite function, and she said it prevents destabilizing production systems.
That sounds like a big deal if you're, a bank or a hospital.
It's critical. When you retrain a model, you risk something called catastrophic forgetting. You teach it a new billing code, and suddenly it forgets how to be polite. Memory-based learning is stable. It doesn't break what's already working.
Speaking of working, we have to talk about the numbers. The cost and speed comparison in this report was pretty startling.
It's not just an improvement, it's a whole different ballpark. They compared MemAlign to DSPy. A DSPy run can cost anywhere from $1 to $5.
Which sounds cheap, but if you're doing that 50 times a day while developing, that adds up fast.
It really does. Now, MemAlign, the cost is about 3 cents.
3 cents, from $5 to 3 cents. That's practically free.
And the time. DSPy takes between 9 and 85 minutes per run. MemAlign, about 40 seconds.
So you're going from waiting an hour and spending $5 to waiting less than a minute and spending pennies. That changes everything about how a developer can work.
It creates what they call tight feedback loops. An expert sees a mistake, gives a correction in plain English, and the fix is live almost instantly. You can iterate 10 times in the time it used to take for one.
And you don't need a huge data set to get started, right?
No, this is what makes it so accessible. You don't need thousands of labeled examples. They showed significant improvements with just 2 to 10 examples.
Wait, 2? Literally just 2 examples?
Yes, because natural language feedback is so information dense. Giving a model a score of 4 out of 5 doesn't tell it why. But saying, this is wrong because you forgot the apology, that one sentence contains a huge amount of learning.
It's the difference between a teacher just marking an answer wrong versus explaining you forgot to carry the 1.
Exactly. And this gets to a new concept they're pushing called memory scaling.
Okay, memory scaling. What are the implications of that?
It's a total shift in how we think about making AI better. We're used to model scaling, just build bigger brain, or test time scaling, throw more computers at the problem. Memory scaling means the AI gets better simply by accumulating more experience over time.
So the model itself isn't getting smarter, its IQ isn't going up, it's just getting wiser.
That's a great way to put it. And they proved it. They took a smaller model, GPT 4.1 Mini.
Which is capable, but it's not the top-of-the-line frontier model, it's the cheaper, faster one.
Right. They put it up against a giant frontier model, a GPT 5.2. After giving the smaller model just 50 examples in its memory, its performance matched the giant model.
You're kidding. So a junior AI with a really good notebook is just as effective as a raw genius coming in cold.
That is the power of context. In a specific business domain, memory beats raw intelligence. You don't need the smartest model. You need the model that knows your rules.
The CFOs listening to this just perked up. You mean I can use the cheaper model, give it a good memory, and get the same results?
Absolutely. And it's better for privacy, too. You can run those smaller models on your own infrastructure much more easily.
And the metrics held up. It wasn't just a one-off thing.
Across the board. They tested it on correctness, faithfulness, safety, fairness. It got over 90% accuracy on things it had seen, which you'd expect.
Yeah, what about stuff it hasn't seen?
That's the real test. And it showed competitive generalization. That proves it's not just memorizing answers, it's actually learning the logic behind the answers.
So, if we zoom out, for years we've been hearing about RLHF reinforcement, learning from human feedback. That was the magic behind ChatGPT. This feels like a pivot.
It is. The industry is shifting to ALHF, agent learning from human feedback.
What's the real difference? Is that just a marketing term?
No, it's a structural difference.
Okay.
RLHF is about training the base model to be generally helpful. It's done by ML engineers at a lab like OpenAI. ALHF is about customizing an agent for a specific job using natural language.
And that's the democratization part, right?
Yeah.
Databricks is building this into their Agentbricks and Judge Builder tools.
This is why it matters to everyone, not just data scientists. It means you don't need a team of engineers to fine-tune your model. You just need a subject matter expert, a lawyer, a doctor, a support manager to just talk to the agent.
Hey, that was a bad response because we never say that to a client.
And the agent remembers. It turns that expert's plain English into a system constraint. It empowers the people who actually know the business to control the AI.
So the subject matter expert becomes the programmer, but their programming language is just English.
Precisely. It closes that gap between knowing what to do and the system that's doing it.
Okay, so let's recap. We're in 2026. The big bottleneck for AI is evaluation. How do you know if it's doing a good job?
And the old ways, fine-tuning, prompt engineering, they were too slow, too expensive, just too brittle for the real world.
And MemAlign comes in and solves this by basically mimicking human memory.
Right. Semantic memory for the rules, episodic memory for the specific experiences.
It lets businesses update their policies instantly with an overwrite button, and it drops the cost from dollars down to, what was it, 3 cents.
And maybe the biggest takeaway. It proves that a smaller, faster model with a good memory can actually outperform a massive model that has no context.
We're moving from training a model, which feels like programming, to educating a model, like mentoring.
It's much more like training a junior colleague.
A junior colleague who never, ever forgets what you told them.
The best kind of colleague.
Hard to argue with that. So here's a thought to leave everyone with. For years, we've been obsessed with base models. Who has the biggest one, the highest score on the leaderboard?
Right, the model's IQ.
But if MemAlign shows that a smaller model with your company's unique memories can outperform a generic genius model, are we getting to a point where the base model matters less than the memories you give it?
That is the billion-dollar question, isn't it? If base intelligence becomes a commodity that everyone can rent, then your company's specific proprietary institutional memory, that becomes the competitive mode. Your value isn't the AI you use, it's the memories you've built.
The value is in the memory. I love that. Something to think about. That's all for this deep dive. Thanks for listening. We'll catch you on the next one.
Goodbye, everyone.